This time it's a slightly different subject. The presentation is about the assessment of the potential impact of driver assistance systems used in automated vehicles on the level of road safety in Poland. And this presentation was prepared together with my colleague from the Institute, Małgorzata Pędzierska, Professor Mikołaj Kruszewski, and Samantha Jamson from Leeds University. Just by way of introduction, I wanted to say that the parts of the analysis presented here are part of the program AVPL Road, Polish Road to Automation of Road Transport. This is financed by the National Center for Research and Development. And it is delivered by a consortium of the Ministry of Infrastructure, Institute of Motor Vehicle Transport, and the Transport Faculty of Warsaw University of Technology. And the main point of this analysis is to look at the development of driver's assistance program and how they'll affect the future. They already have an impact, but they are expected to increase the impact. They are expected to change comfort, but most importantly, they're expected to affect the road safety. Most accidents are caused by human error. That is why we hope that the implementation of those systems will be crucial. The identification of the systems and how they affect the general impact on road safety is also very important, because we know that every system is slightly different and operates in a slightly different way. It is also worth estimating the number of vehicles which are equipped with driver support systems, because using those systems could have a significantly positive impact on road safety. And the purpose of this presentation is to present to you and describe the relationships between the effect of those systems in the impact of those systems in vehicles on road safety in Poland. Now, methodology. When we worked on the forecast, we analyzed all the available statistical data. The estimates were based on multiple expert opinions that were available to us, but the process of putting the various analyses together, because we used expert analyses and that had different assumptions in many cases. Putting them all together gives us a fairly broad picture, allowing us to describe that phenomena as in a relatively full way. So our forecasts for the period ending in 2030 were related to a variety of factors, such as traffic intensity, the development of the passenger cars fleet in Poland. So the analysis we carried out allows us to relatively, with good precision, forecast and project the development of the situation in Poland, and this is the result. These are tables. The estimates for the period ending in 2030 were done for four variants, for four options, showing how the introduction of those systems could gradually reduce the number of accidents. In addition to the table, which I'll return to in a moment, the presentation discusses the systems, their potential operation, and their potential impact on road safety. Causes of accidents were connected to systems that could possibly prevent them. Also, we've estimated the number of vehicles that would be equipped with these sort of support systems. So based on this, we've created the 4 versions. The first version is the limitation of road accidents by 0.83% from year to year over 10 years. This version was based on the estimation of the modern vehicles moving in Poland or registered in Poland under 4 years and 4 years and newer, from the highest segments that are more frequently equipped with driver support systems. This was based on the data from the years 2014-2018. Based on that, we estimated the possible or extrapolated the future situation for the period ending in the year 2030. So that's how we arrived at the conclusion that it will be approximately a little less than 1% per year. The second option is 1.07% year to year. That estimate was based on the trend from the last 10 years. Which was really, the main factor was really the changing age of an average car and the age structure of the total number of cars in Poland. The third version predicts 1.17%. This bases on the data from 2018 and takes into account the average age or the age structure, but this is a progressive option which assumes more variability in terms of vehicle age and the year in which a given age will be, let's say, introduced to the market. And the fourth option is the most optimistic, assuming 2.78% reduction on average every year until 2013. This is based on the estimation of how accidents that occurred in 2018 could be reduced based on the extrapolated number of vehicles equipped with the systems. This is actually similar in the calculation to the trends, the version that is based on the trends over the previous 10 years, because the number of accidents was being reduced. So taking into account the average value of these 4 estimations, we could assume that this is perhaps the middle version that is that has the highest certainty. Based on that, we estimate that in 10 years' time we will have probably approximately 5,000 less accidents, road accidents. Here is the graphical presentation of the 4 options. The most optimistic is the yellow one, as you can see. In conclusion, the presented forecast is an objective characteristics of the possible future scenarios for reducing the number of accidents and developing a fleet of passenger cars equipped with autonomous driver assistance systems. Of course, as vehicle automation grows, human participation in driving will be reduced. The human factor, therefore, will be minimized or eventually eliminated, and that will improve road safety. But of course, it is quite obvious obstacle is to persuade people to go along with it. It is also important for people to have knowledge of the systems available in the vehicles and how they need to be used. Thank you very much for your attention.